Welcome to this lecture on the rotational dynamics. जहाँ तक हमने अभी moment of inertia और उसकी बाकी properties की बात की, we have determined the moment of inertia of different rigid bodies of different shapes. Now we take up the concept of kinetic energy in case of a rigid body. The kinetic energy as we define in case of translational motion, which I call as the kinetic energy of translational motion, is defined as 1 by 2 mv square. लेकिन यहाँ पर जब हम एक रिजिड बॉडी की बात करते हैं, which velocity we have to take, क्योंकि अब ये एक सिंगल पॉइंट तो है नहीं, this is a mass which could be extended mass like this. So we have seen कि जब हमारे पास ऐसी सिचुएशन हो कि एक एक्सटेंडेड मास हो, so the physics says कि इस केस में आप इस बॉडी पर आइडेंटिफाई करें कि इसका सेंटर ऑफ मास कहाँ है, उस सेंटर ऑफ मास का वेलोसिटी आप मेजर कर लें. सो इन दैट सेंस जो अब इसकी काइनेटिक एनर्जी होगी, द काइनेटिक एनर्जी ऑफ दैट रिजिड बॉडी विल बी हैविंग वन ऑफ द कंपोनेंट्स, जो उसका एक कंपोनेंट है, दैट कंपोनेंट इज काइनेटिक एनर्जी ऑफ ट्रांसलेशन विच विल बी 1 by 2 into VCM whole square. VCM is the velocity of center of mass whole square. Now this way we can imagine कि अगर मेरे पास एक स्फीयर है या एक रिंग है या एक डिस्क है, उसका जो सेंटर ऑफ मास है वो कहां पर है, उस सेंटर ऑफ मास की वेलोसिटी को लेके we can multiply the square of that velocity to 1 by 2m and we get the kinetic energy. For example, अगर ये मेरे पास एक स्फीयर है, this sphere has center of mass which is the center of the sphere, और जैसे ही स्फीयर बढ़ता है आगे we can see कि what is the velocity with which its center of mass is advancing forward, and that velocity when we use here we have the velocity square multiplied to 1 by 2m. But it is possible sometimes कि अगर ये एक parallel center of mass इस surface के parallel चला, we will call it simply as the slipping or sliding of the body. What would happen कि अगर ये parallel चलने के साथ साथ ये body roll भी कर रहा है, that means there is a rolling motion which accompanies the motion which is translational. In that sense, it comes to possess another kinetic energy which we call as the kinetic energy of rotation. Or how do we define kinetic energy of rotation? We define it as 1 by 2 I omega square. And which is this I? I is moment of inertia, or this is the moment of inertia with respect to an axis passing through the center of mass. और if you remember कि आपके पास जो ये ICM है, इस ICM की वैल्यू हम अलग अलग केसेस में कैसे निकालते हैं, you have already done that कि डिस्क का कैसे निकालेंगे, स्फीयर का कैसे निकालेंगे, सिलेंडर का कैसे निकालेंगे, रिंग का कैसे निकालेंगे. So that way we have to find out that the energy which this body possesses now is to be possessed in two forms. The first form is that it can possess a kinetic energy because of translational motion, and then it possesses a kinetic energy because of rotational motion. Sometimes another expression which is of use to us is that moment of inertia is equal to m into k square. What is k here? K is radius of gyration of the rigid body, and we can use this expression to write the total kinetic energy now. So kinetic energy total of the rigid body will be equal to kinetic energy translational plus kinetic energy rotational. And as you see that kinetic energy translational, which is equal to 1 by 2 m VCM square, and then we have the kinetic energy rotational which is equal to 1 by 2 ICM omega square. Omega is the angular velocity. We may also write this as 1 by 2 m into VCM square plus 1 by 2 into, देखिए ICM को मैं लिख सकता हूँ m k square into m k square, here k is radius of gyration, plus this into omega square. तो अब आप इसमें से अगर आप कॉमन ले लेते हैं 1 by 2 m, I'll have VCM square plus this is k square omega square. So this way what we find is कि अगर अब ये रिजिड बॉडी एक ऐसा ऑब्जेक्ट है जैसे एक स्फीयर हुआ या एक रिंग हुआ, I have further one more simplification in that case. What will be that simplification? That simplification will be कि मैं जो इसका VCM है, linear velocity of the center of mass, उसको मैं ऐसे लिख सकता हूँ. So I can call VCM as omega r. We remember the relation for rotation that velocity, linear velocity is equal to r omega. What's r now? R इसका radius है. That is the radius of this rigid body. So in that sense, what will be kinetic energy total? This kinetic energy total will come from here. So this will be 1 by 2 m into VCM square will become r square omega square. VCM square will be r square omega square plus k square omega square. So I may write this as kinetic energy total is equal to, अगर मैं अब omega square को common निकालूं, so I get 1 by 2 m omega square into r square plus k square. So this is how we write the kinetic energy total of a rigid body. Now we can apply this concept to a situation like this कि अगर एक rigid body जैसे एक रिंग हुआ या एक डिस्क हुआ या एक सिलेंडर हुआ, अगर ये एक inclined plane पर हम रखें और इसको एक inclined plane पर roll down करें. See, this is an inclined plane. If there was a ring like this जो इस पर ऐसे slide कर रहा था, so it would possess only the translational energy. That way जो इसकी kinetic energy होगी that will be simply equal to 1 by 2 mv square. लेकिन अब अगर ये ऐसे roll कर रहा है, here is the rolling motion along with the translational, it will possess both kinetic energies. जो इसका total kinetic energy होगा that will be sum of the kinetic energies as I said. Now it happens like this कि अगर हम इस object को रखें और हम इस plane को incline करें, this object starts rolling down the incline like this. और when it rolls down the incline, I find कि जो इसकी kinetic energy है, that kinetic energy which it will possess will be both the translational as well as the rotational. Now here surprisingly you will see कि friction जिसको हम ये मानते हैं कि एक ऐसा force है which always tries to destroy the relative motion, but in this case you will see interestingly कि friction is something which is going to cause the rotation. अगर friction absent हो, there would be probably no rolling without the body. It would be, अगर friction नहीं हुआ तो it would be just slipping down, not rolling down. So we have to see that what is the role of friction, and we try to get some equations furthermore, and we take up this case in the form of a body sliding down an incline, and once the incline is frictional, there will be rolling as well as the body will be moving in a translational manner. So we go back to some of the concepts जो हमने already pick up किए हैं in the simple dynamics of a inclined plane or motion of a body along an inclined plane. What we have seen in that case, हमने ये देखा कि if we make a body to fall freely, what will be the outcome of its free fall? The outcome of its free fall will be like this: if there is an object of mass m, this is an object of mass m which we are allowing to fall freely, it will have an acceleration downwards. That acceleration is the acceleration due to gravity g. Now if the same object is made to fall but we give it a support, the support is we allow it to fall along an incline, और इस incline में कोई भी friction नहीं है, there is no friction is present, right? What will happen is कि जो ये object है, जो उसका weight mg है, this weight mg will be resolved into two components. अगर ये theta है, then you will agree कि if this angle is theta, this angle is also equal to theta. So this is equal to mg cos theta. This force, the component in this direction is mg sin theta. Or you will see कि there is no friction. जो friction अगर present होता, that would have opposed the motion of this ball or this mass downwards. So the only force which is acting on the body is F equal to mg sin theta, which is trying to cause the motion downwards. If I write F equal to ma, A is acceleration of the body, equal to mg sin theta, what I obtain from here, m and m gets cancelled. I obtain that acceleration of the body, which was earlier equal to g, has now turned into g sin theta. and g sine theta, as you see, is the acceleration of this body down the incline when there is no friction present between the inclined plane and the body. But we now come back to the situation where the body has an incline and that incline is frictional incline. So imagine कि ये मेरे पास एक inclined surface है अब. So this is an inclined surface. This is an object which is rolling down, and this object I take for convenience in the form of a disc or in the form of a sphere which is rolling down the incline, और यहाँ पर अब friction मौजूद है. This is a frictional surface, and as such जैसे ये body tendency रखता है to move down, so I go about resolving ये इसका mg है, then this is mg cos theta, mg cos theta, this angle is theta, this angle is theta, angle of inclination, and this is mg sin theta, and there will be a force of friction. That force of friction is present here somewhere, जो ऐसे इसकी motion को oppose करेगा. और you will see from this diagram कि जो ये force of friction है, it has a moment of the force. अगर ये इसका हम center लेते हैं body का center of mass, तो this force of friction has a moment with respect to point O. Moment आपको याद होगा is the product of force and distance. And what is that moment of force? That moment of force we have also called as the torque. तो मैं एक बहुत ही important relation बाद में use करूंगा, that when I say that torque, what is torque? Torque we can express in two forms. We can use an analogy of this equation that F is equal to m into A, torque is equal to moment of inertia को हम replace करते हैं with the mass, और A becomes alpha here. So I have this relation that torque is equal to I into alpha. And I also have another relation which says that torque is equal to moment of the force. अगर मैं इस force का moment निकालूं with respect to O, you see there is a perpendicular distance between this point, यहाँ पर एक axis pass हो रहा है ऐसे, and there is a distance r between the point where force is acting and the value and the position of O. तो ये जो distance है, this distance is r. You will see कि the moment of this force of friction becomes equal to Fr. R is radius of this body. अब ये जो दो relations हैं, these relations could give us something like this, कि if I put I alpha is equal to Fr, then alpha you understand is linear acceleration, जो alpha है, that is linear acceleration divided by radius. So what we see further is कि जो ये linear acceleration अगर body का A है, that linear acceleration A is related to the angular acceleration, is that alpha becomes equal to A is linear acceleration divided by R. तो यहां से हमें क्या मिलेगा? We will obtain that if I write alpha equal to A by R, so I have moment of inertia multiplied by A is linear acceleration divided by R is equal to Fr. So I have an expression for force of friction in terms of linear acceleration and radius, so it becomes I into A divided by R square. Now come back to the equation कि ये आप ध्यान में रखें that when there was no incline, the acceleration downwards is g. When there is a frictionless incline, the acceleration is g sine theta. Let's see what will happen if there is a frictional incline present and the body is rolling down, which is more practical. This situation is more practical. अब यहाँ पर देखें, there are forces acting on the body. There is a force mg sine theta which is trying to move it downwards. There is a force of friction which opposes it, and then this friction and this mg sine theta, they will be deciding what will be the net acceleration of this body. So if I say that F net which is acting on the body, that F net is equal to mg sine theta minus F. Now what you see is कि जो ये F net हम ले रहे हैं, this F net is the force acting on this body, which will be mg sine theta minus small f. Small f is force of friction. So I can write it as m into A net is equal to mg sine theta minus. What is force of friction? Force of friction हमने already देखा है that it is I into A net डिवाइडेड बाय ये जो a है ये असल में a नेट है डिवाइडेड बाय r स्क्वायर। अगर इन दोनों इक्वेशंस के साइड्स को हम m से डिवाइड करें सो आई विल सी दैट a नेट बिकम्स इक्वल टू, यहां से m कैंसिल आउट हो जाएगा, सो आई एम डिवाइडिंग विद दिस m and m get cancelled, we have g sin theta minus I a net divided by mr square, or shift this quantity to the left hand side, this will be a net plus I into a net divided by mr square is equal to g sin theta. Now bring in the value of I, will be doing it in the next step, तो ये रहेगा a net into 1 plus I divided by mr square is equal to g sin theta. अब यहां जब आप I की बात करते हैं, this I can be written as m into k square. What's k there? K is radius of gyration of the rigid body. So we can write this as a net into 1 plus I की जगह m k square divided by mr square is equal to g sin theta. And once I cancel out m and m, I have the final expression जो a net होगा, this a net would be equal to, so a net is equal to g sin theta divided by 1 plus k square divided by r square. So what you see further is कि जो ये expression अब है, हमने देखा कि initially when the body was dropped down in the form of a free fall, the acceleration due to gravity was g. Then when it slided on a frictionless incline, its acceleration got reduced. That reduced value was g sin theta, and that would become maximum equal to g if sin theta is equal to 1. When does sin theta become equal to 1? When theta is equal to 90 degree. But now you see that this has further got reduced, क्योंकि अब जो friction के आने से जो इसका net acceleration है, that has further got reduced, and that reduced value is given by a net equal to g sin theta divided by 1 plus k square by r square. Now a question which is sometimes asked is कि अगर हम एक ही incline पर जिसमें friction present है, we have three shapes, one is a ring, other is a disc and other is a say sphere. तो हमने एक ही incline पर पहले एक रिंग को ड्रॉप किया और उसको रोल डाउन करवाया, फिर हमने एक स्फीयर को रोल डाउन करवाया. सो व्हाट विल बी द एक्सेलरेशन ऑफ ईच वन ऑफ देम? हियर यू विल सी दैट मोमेंट ऑफ इनर्शिया कम्स इन टू प्ले द रोल. अगर आपको याद है कि जो मोमेंट ऑफ इनर्शिया होता है रिंग का विद रेस्पेक्ट टू एन एक्सिस passing through the center and perpendicular to its plane. Now this axis which is passing through the center and perpendicular to the plane is also parallel to the incline, क्योंकि जो हमारा incline है, this incline is going to be a surface like this. So जब आपने इस पर एक रिंग को रख दिया, here is the incline, जब आपने इस रिंग को इस पर रख दिया, जो रिंग का जो moment of inertia है, that has an axis which is parallel to the incline, so that is equal to mr square. Then if it was a disc, in the same manner, it would be equal to mr square by 2. And if it was a sphere, solid sphere, this is equal to 2 by 5 mr square. Now can I find out that what would be the net acceleration in these three cases? Or remembering जो थीटा है वो तीनों के लिए कांस्टेंट है और जो इन तीनों का रेडियस है वो भी सेम है. मे बी देयर इज सम डेंसिटी डिफरेंस जिसकी वजह से हम मास को भी इक्वल मेंटेन कर रहे हैं. और इन एनी केस जो इसका मास है दैट डज नॉट एंटर इनटू द फाइनल रिलेशन, वो कैंसिल आउट हो चुका है. सो व्हाट आई गेट ए नेट इक्वल टू वी हैव g sin theta divided by I have now 1 plus. देखिए सबसे पहले हम a net निकालेंगे for the ring, so I'll call it as a ring. So for ring what will be the result? The result will be, देखिए when I see that what's moment of inertia is mk square. तो इसमें से अगर हम निकालते हैं that I write mk square is equal to mr square. So I have moment of inertia of the ring given by mk square. That moment of inertia is equal to mr square. M and m will get cancelled. K square is equal to r square for this. So you will see कि जो k square और r square का ये ratio है for a ring, this ratio will be equal to 1 because k square by r square becomes equal to 1. So this will be 1. So your answer will be g sine theta divided by 2 for a ring. Let's repeat this procedure for the moment of inertia of a disk now. Disk के लिए जब हम ऐसे लिखते हैं mk square is equal to mr square by 2, what you'll see is m will get cancelled, k square by r square will become equal to 1 by 2. So what will be the result here when I find moment of inertia, this net acceleration for a disk? So disk के लिए ये हो जाएगा g sin theta divided by, so this will be 1 plus, यहाँ पर k square by r square की वैल्यू है 1 by 2, so which will be equal to g sin theta divided by 1 plus 1 by 2 is 3 by 2, so this would be equal to 2 by 3 g sin theta. That way we can further go to find out कि sphere के लिए क्या होगा. Sphere के लिए आप देखें, so sphere के लिए I have mk square is equal to 2 by 5 mr square, 2 by 5 mr square. So जब आप m और m को cancel out करेंगे, you will get k square by r square for a sphere is equal to 2 by 5, So what would be the value for a sphere? For a sphere, this will be equal to g sin theta divided by 1 plus 2 by 5, 1 plus 2 by 5, that is 7 by 5, or it will be 5 by 7 g sin theta. अब आप इस फ्रैक्शन में देखेंगे कि when I take 1 by 2, this becomes 0.5 g sin theta, or when I talk about 2 by 3 becomes equal to 0.6, so this is 0.66 g sin theta, and when I take 5 by 7 we have 0.7 g sin theta. तो अब आप इन वैल्यूज की बेसिस पर बता सकते हैं कि नेट एक्सेलरेशन विल बी मैक्सिमम इन केस ऑफ स्फीयर, the net acceleration will be slightly lesser in case of a disk, and the net acceleration will be least in case of a ring. So that way अगर हम ये imagine करें कि एक ring और एक sphere और एक disk, they run a race on the incline has same value of theta for all the three, or force of friction is same for all the three, what will be the value of their net acceleration? The race will be won by sphere will have more net acceleration down the plane, and followed by the disk and followed by the ring. So there is now a very vital role played by moment of inertia of the given object, and that decides its net acceleration. और moment of inertia की basis पर हम देखेंगे कि you could think of the radius of gyration of the object, and that gives the given result. अब इस चीज को अगर हम डिराइव करना चाहें, यहां पर हम काइनेटिक एनर्जी और पोटेंशियल एनर्जी की बेसिस पर भी इस एक्सप्रेशन को डिराइव कर सकते हैं. यू कैन सी सिंपली रिजल्ट विच वी कैन ऑब्टेन लाइक दिस आल्सो, बिकॉज आमतौर से जब भी हम मैकेनिक्स की प्रॉब्लम्स करें, वी मस्ट बी एबल टू यूटिलाइज द लॉ ऑफ कंजर्वेशन ऑफ एनर्जी टू द बेस्ट पॉसिबल मैनर. दैट मेक्स समटाइम्स सम वेरी ट्रिकी प्रॉब्लम्स वेरी सिंपल. देखिए, मैं यहां मानता हूं कि ये एक ऑब्जेक्ट था यहां पर. दिस ऑब्जेक्ट फॉल्स थ्रू अ डिस्टेंस L, reaches here, or if I take this angle as theta, then you will agree that this angle is also equal to theta. Now the net height which this object has lost is h. This is the net height. यहां पर देखें इसकी height, so I could make it slightly better like this, कि अगर मैं यहां से इसके center of mass से लेता हूं line, और here I have the line like this. So the center of mass has fallen through height h, and this angle is theta. अब आप देखिए h और l में क्या रिलेशन है. h और l में ये रिलेशन है कि अगर मैं इस ट्राइंगल में sin थीटा की वैल्यू ले लूं, sin थीटा becomes equal to perpendicular divided by hypotenuse. So h becomes equal to l sin theta. So this is equal to l sin theta. You will see that what was the initial state of the system. Initially it did not have any kinetic energy, और जब ये यहाँ पहुंच गया from point A to B, it has gained a kinetic energy. Now at this position it possesses two forms of kinetic energy. What are those two forms of kinetic energy? Those two forms of kinetic energy are, it has a translational kinetic energy and it has a rotational kinetic energy. And what is the translational kinetic energy plus rotational? It is 1 by 2 mv square plus what is the rotational? That is 1 by 2 into I omega square. So these are the two kinetic energies possessed by the body. So this is what is called as the gain in kinetic energy. So gain in kinetic energy. Now what is this gain in kinetic energy? It must be equal to loss in the potential energy. And what is loss in the potential energy? Loss in the potential energy, you will agree with me, is equal to mgh. So loss in potential energy is equal to gain in kinetic energy. What is loss in potential energy is m into g. M is mass of the body into g into h. H will be later L sine theta. And what is gain in kinetic energy? It is 1 by 2 m v square plus 1 by 2 I omega square. और इस एक्सप्रेशन को हम थोड़ा सा next. So what is now mgh? Mgh is equal to 1 by 2 m. Can I write in place of omega? So this is 1 by 2 m v square plus 1 by 2 I. Can I write in place of omega v by r? Yes. आपको याद है v is equal to r omega. So omega becomes equal to v by r. So this is v by r whole square. हम इसके लिए capital R use करते आए हैं. So I write it as capital R. So I have mgh is equal to 1 by 2 m v square plus 1 by 2 I into v square divided by r square. So here I can cancel out. अगर मैं इसको cancel out करूं, I divide both sides with m. M gets cancelled out here, and this becomes something like this. You can do it in the next step now. So this would be mgh mv square. So I can say from here that gh, या अगर हम इसको if we leave it for a while like this, तो मैं यहाँ पर I को अब replace कर देता हूँ. So let me write as mgh, क्योंकि इस स्टेप में अगर यहाँ भी m आ जाए, that would be cancellation throughout. तो 1 by 2 I की जगह can I write mk square? Yes. What's k here? Radius of gyration. v square divided by r square. अब आप m को cancel out कर सकते हैं throughout. m and m gets cancelled out. So we get something like this, that we have, अगर मैं यहाँ 1 by 2 common ले लूँ, so I get 2gh is equal to, ये रह गया v square, और यहाँ है आपके पास plus v square into k square divided by r square. So what will be now v square into 1 plus k square by r square? This would be equal to something like v square would be equal to 2gh divided by 1 plus k square divided by r square. और आपको याद है कि h की वैल्यू जो है that we have already taken equal to L sin theta. So L is the distance traveled by the body. तो मैं h की जगह लिख देता हूं L sin theta, so that we get v square equal to, so we have v square equal to 2 into g into h की जगह L sin theta divided by 1 plus k square by r square. And what I further do is कि since this motion is going to be a uniformly accelerated motion, अगर इसमें force एक friction का present है, एक this mg sin theta present है, the net acceleration is going to remain constant throughout. तो मैं ये relation use कर सकता हूँ. If I say v square minus u square is equal to 2as, what will happen in this case? In this case, v square will be the final velocity here. So this is final velocity here. Here the initial velocity was u, which was equal to 0, minus 0 square is equal to 2 into a net. A net is now the net acceleration. The distance which this body has traveled is L. So can I write in place of V square becomes 2 into A net into L. So here I have V square equal to 2 into A net into L is equal to 2 GL sine theta divided by 1 plus K square by R square. And there is cancellation of 2 on both sides. There is cancellation of L on both sides. So I obtain A net is equal to, I have G sine theta divided by 1 plus K square by R square. Here is the expression जो हमने already derive किया हुआ है. The only change is that this expression we have arrived on the basis of law of conservation of energy. We see that as the body rolls down the inclined plane, there is a loss in potential energy and there is a corresponding gain in the kinetic energy. The only change now is that this gain of kinetic energy is not only in terms of the translational kinetic energy, there is another component of the kinetic energy in this case, that is rotational kinetic energy, and this can be assumed as a very important type of relation in the terms of the phenomena which we see in day-to-day life. Because आमतौर से हम जब देखते हैं when a body is rolling down along an inclined plane, there is always some friction present and that makes the body to roll down. अब अगर आप ऐसा सोचते हो कि there was no friction present, no friction would mean that there was no value of alpha, there was no angular acceleration. When there is no angular acceleration, the body will not roll down the inclined plane, it will slip down the inclined plane. That means it will slip down without rolling. That's called as slipping without rolling. So what would be the outcome is that if there was no friction, there would be definitely no rolling, there would be only slipping of the body down the inclined plane, जिसका expression हमारे पास already है G sin theta. But the coming of friction brings in G sin theta divided by 1 plus K square by R square. So this will be a very useful relation for solving the problems of rotational dynamics. Thank you.